Here's the last two problems in section 4.2, number 6 and 7. Number 6 says, you roll two fair dice, one green and one red. First of all, are the outcomes on the dice independent? Yes. One die has no effect on the other, so let's claim that yes, they are independent. Find the probability of a 5 on the green and a 3 on the red. So what I want is probability of a 5 on the green, and I'm going to use this symbol for and. It's an intersection sign. 5 on the green and a 3 on the red. All right, well, they are independent, so I can just multiply them together. Probability of a 5 on the green times the probability of a 3 on the red. So 5 on the green, that would be 1/6. 3 on the red is 1/6. So I'm going to claim this is 1/36. And they are asking us, I kind of wrote over it, but enter your answer as a fraction. So I'm going to enter this one as 1/36. Now what about part C? 3 on a green and a 5 on the red. Well, all right, this is the probability of a 3 on the green and a 5 on the red. They're still independent, so I still think it's going to be 1/6 times 1/6. So 1 out of 36. Now, what about this part C? Well, what do we want here? A 5 on a green, 3 on the red. Okay, that was part B. Or a 3 on the green and a 5 on the red. That was part C. So I got an OR here. All right, so I'm looking at an OR. Now, if it's an OR, I ask myself, are these events... No. I ask myself, are they mutually exclusive? I'm going to say yes, because if I get... Suppose you do this. If you get a 5 on the green and a 3 on the red, you cannot at the same time get a 3 on the green and a 5 on the red. So I'm just going to add these together. So I'm going to get 1/36 plus 1/36. So how about 2 out of 36? Or if that might be good enough. I don't know how they're taking it. Or 1 out of 18 if you reduce it. Number 7, you draw 2 cards from a standard deck of 52. But before you draw the second card, you put the first one back and then reshuffle. Okay, part A. Are the 2 outcomes independent? Yes, because you're doing, you're sampling with replacement. So the answer is yes. So yes, the events can occur together. Yes, the probability of drawing a specific card on the second is the same regardless of the identity of the first card. That is true. So I'm going to go with this selection right there. Part B says, find the probability of an ace on the first and a king on the second. All right, so what I want here, this is 7B. I want the probability of an ace on the first, and a king on the second. Okay, well, it's with replacement, so they're independent. So I'm going to do this. Probability of an ace on the first times the probability of a king on the second. Well, there's 4 aces out of 52 cards. And there's 4 kings out of 52 cards. I can make this multiplication go a little bit easier if I just do this. 4 will go into 4 once into 52 13 times. Same thing over here. 4 into 4 once, 4 into 52 13. Then I end up with 1/13 times 13, 1/169. All right, so find the probability of a first ace on the first, king on the second. I'm going to claim this as 1/169. Now, look at this C. A king on the first and an ace on the second. That's the same as what we just did here in part B. That's going to be 1/169. And then part C, this is going to be the OR, right? Find the probability of drawing an ace and a king in either order. All right, so in either order, see when it says either order here, what you're thinking is you could get this. You could get, I'm going to write it like this. You could get an ace on the first and a king on the second, or you could get a king on the first and an ace on the second. Okay, that's the way you can get that. Now, we just found this one to be 1 over 169. This one was 1 over 169, and I've got an OR. They are mutually exclusive because if you get an ace on the first and a king on the second, you can't be looking at the same time getting a king on the first and an ace on the second. So I'm going to add these together. So I get 2 over 169. So I'm going to claim that, 2 over 169. And we're done.